you know, we're super excited to have Matt Chasen, the founder and CEO of Lift Aircraft, here to talk about their Part 103 compliant ultralight aircraft called Hexa. And usually we say we've got a guest star, but we're super lucky and proud that Matt's actually one of our own, and he's a working group #1 contributor, as he was a contributor to working group 4 with Johnny Dew and the gang over there. So a little bit about Matt's background, which is really cool, and I'm kind of jealous because the guy just can't stop succeeding at everything he does. But he got us started in the honors engineering program at University of Texas in Austin, slid right into some very cool projects. He was involved with the NASA Lars research program and in the 90s, jumped in with Boeing as a senior systems engineer, working on some really cool projects, including the F-22 Raptor. Bounced right from there to you know, take his aviation experience and build on business, and did an MBA at University of Texas. While he was there, because getting an MBA isn't hard enough, he started a business, and the business was in online shipping. There's a company called UShip, and it was the largest online marketplace for shipping with over 200 million in annual gross sales. And he still keeps an eye on that organization. Then he jumped into co-founding a really cool app called Hitch that's sort of like Lyft or Uber, but for intercity travel, sort of reinventing the old hitchhiking model in a safe way. And then about 5 years ago, in 2017, he founded Lift Aircraft, where he's currently the chairman and CEO, and the organization is doing some really cool stuff. And so we're just thrilled to be able to hear this talk today. So Matt, please take it away.
Thank you, Andy. Appreciate that intro. Let me share my screen, which we rehearsed here, so hopefully will work. Oh, I think it would work if I picked the correct screen. Hang on. Let me read. Yeah. First glitch. Okay. Well, great to chat, everyone. Some of you I know, and I gave a similar talk to Johnny's Public Services Working Group not too long ago, so this is going to look somewhat familiar. Likely, is everyone seeing my screen?
Yep.
Yes. Okay. Awesome. So delighted to kind of share some updates with you all today. I won't go spend too much time talking about the background for eVTOL to this group, but as we all know, urban congestion has kind of reached epidemic proportions. And you know, we firmly believe that we have to go up to solve the problem, in addition to fixing ground transportation. You know, it occurred to me a while ago, seeing lots of really cool aircraft being developed that are suited to kind of a 50 to 150 mile range, that kind of mission with 4 or 5 seats, that, you know, is kind of for this, you know, emerging air taxi market. You know, we dug in to try to find what we think the biggest problem in urban air mobility or urban congestion is really. And it turns out that, you know, predominantly the vast majority of trips, and this is intuitive to all of us because we're the ones driving these things, that 85% of car trips today are just very short range, less than 15 miles. And 90% are just the driver, right? Single occupant. So we, with Lift Aircraft, decided that we would focus on a very specific segment within urban air mobility that we call aerial micromobility, right? So this is short range, low altitude, single occupant. And I say short range, we're kind of defining this as kind of sub 15 miles. And you know, we're not aimed, of course, initially at fully autonomous aircraft. These are piloted. vehicles. And because of the mission, we decided to, focus on a design or configuration that is just purely a hover aircraft, right? So focus on simplicity. Many of you know, transition aircraft are theoretically capable of longer ranges and more efficient cruise, but all of that comes at a sacrifice to hover efficiency and safety. And so for short range, we felt like a pure hover vehicle was the best and safest route. And then I'll go into more detail, but we envision many small neighborhood scale vertiports, even point-to-point sort of end building, end home, point-to-point transportation in the future, as opposed to sort of larger scale vertiports. So this all resulted back in late 2017 in us designing Hexa, right, which is our eVTOL aircraft. And, in addition to thinking that this like single occupant short range vehicle could help to solve sort of the urban congestion crisis, we also designed it specifically to fit into ultralight rules, Part 103. And, that was wonderful. Design problems are hard enough. It was really wonderful to have the rules of Part 103 to sort of put limits on the design space for us. So we were able to really quickly design and prototype Hexa and get to flying unmanned and then manned. And we've already done to date, I think, well over 700 test flights. I think we're closer to 1,000. And actually, after 4 full-scale prototypes, we actually entered production in 2020. We're still kind of in low-rate production. I'll go into more detail as well, and have our first couple of vertiports in development already. So I'll kind of dive in a little bit more into Hexa's design. First thing that jumps out, of course, is that it's an overhead rotor design. It's pretty straightforward. Looks kind of like a helicopter instead of one rotor. Of course, it has many. It has 18, in fact, and that number sort of came out of a weight minimization kind of problem with using pretty much commercially available BLDC electric motors and the whole powertrain units, including the speed controller and the battery, in the right voltage and power levels to get the payload we need for the aircraft and to fit into Part 103. The wonderful thing about having so many motors, it looks a bit interesting, but we can lose multiple motors, so multiple motor fault tolerant. In fact, depends on which 6. It's very statistically unlikely to lose a motor. Electric motors are highly reliable. And so it's going to be very infrequent. And so, you multiply that very low probability times up to 6, you get an extremely low probability of losing a sufficient number of motors to actually lose control of the aircraft. In the event that something happens that causes loss of control of the aircraft, we have, very importantly, a ballistic parachute that you can see in the center of the rotor plane at the top. And that's a key design feature. In a sense, you can kind of see that we designed the whole aircraft around this. It's a wonderful benefit of multi-rotors that you have, a hole in the center potentially where you can put a ballistic parachute. And it's not just any ballistic parachute, it's one that is effective at very low altitudes and with no forward speed. So it's designed for drones and multi-rotors. And there's actually a company based in Israel who developed the technology that we're using for that. So yeah, I'd say that without the existence of that parachute, we probably wouldn't have done this, or we'd have had to develop something similar ourselves. We also, importantly, with eVTOL aircraft, as you all know, you get mechanically simple electric powertrains, but but then you shift some of that complexity into the flight control system. So we have a 3 times redundant, we have a triple redundant flight control system with the ability to add a 4th dissimilar autopilot into the mix with a pretty sophisticated arbitration system to determine kind of which autopilot's flying at any given time. And it automatically controls for, motor failures and other failures in situations, senses it, and that's pretty typical drone flight control. Another interesting design aspect to Hexa is we got a fully distributed battery system. So instead of 1 or 2 or 3 central battery packs, you need a couple for redundancy. We just said, let's give each motor its own battery pack. And that might seem like it'd be really annoying to change battery packs out in between flights. And you're right about that. If we were actually going to sell these to people, that would be a bit of an annoying feature. But our model is not to sell these to people, but rather to rent them to people and have our own ground maintenance folks actually do the battery charging and battery swapping. So that has a lot of benefits in weight, power cabling weight, as well as safety. And if there is a thermal runaway in a battery, it's pretty contained and it's away from the pilot, and it's smaller in scale. So I won't go through each of these, except to say, you'll notice also the floats at the base. We have 7 total. And this is for safe emergency landings over water or normal operations over water. I think we'll expand to amphibious operations at some point. I think it's probably best. I'm sure a bunch of people have questions, so why don't let me just rock through this and we'll save plenty of time, I think, for questions. I mentioned that we're going to rent the aircraft to people instead of sell. That's a key decision we made early, and it even kind of made its way into the design, as I mentioned. So what we're doing is launching vertiports where we own and maintain fleets of Hexas, provide training in our VR simulator. We will have our own sort of mission control and air traffic control personnel that are monitoring telemetry in real time from your aircraft and can, in fact, under certain circumstances, take over control. You get into a bit of a legal gray area when it comes to that, but that's possible in emergency situations. And these vertiports will be in areas that are known, so we can geospatially map the flight area to a really fine degree, which will include our ability to sort of create geofenced or geocaged areas that we allow people to fly in boundaries where pilots are not allowed to fly. For example, into controlled airspace, which is not allowed under Part 103 unless you have permission. We also can control for weather to a large extent, right? Pretty short flight times, fixed areas. We just won't let people take off unless the weather is VFR and good, per the performance of the aircraft. So really, from a safety standpoint, we looked at all of the causes of general aviation accidents and focused, of course, on the top 10 and tried to figure out if you just reimagine and reinvent personal flying, what would it look like? And how can you make it safer, right? An example is, controlled flight into terrain or fuel exhaustion are 2 leading causes of fatal accidents. Well, those are things we can, with technology, we can sort of control, against by, an automatic return to home or automatic emergency landing for low battery states, and obstacle avoidance and geofenced flight areas, when it comes to terrain avoidance. So really kind of rethought we're not just creating an aircraft, but creating a whole sort of flight experience that we think will enhance safety a lot. And so, go through kind of some milestones on the development of the aircraft. As I said, we started the design in early 2017 and did some testing with a 1/5 scale prototype. We were able to quickly get to write a full scale prototype. For us, the big challenge was not, this is just a multi-rotor. We knew it could fly. We don't have super complex aerodynamics to try to work out like with wings. So really the challenge was, can we build this and have it be light enough to fit into Part 103? And so that's why we needed to get quickly to a composite airframe and start doing testing on it. And thankfully, we've been able to do that. In fact, after I mentioned a few prototypes, we actually partnered with a tier 1 aerospace manufacturer called Carbon Aerospace. Most people know them. They were a subsidiary of Triumph Aerospace until they were spun out a couple of years ago. And we have since kind of delivered the first few of our production aircraft to partners and customers and for testing. This has been a wonderfully fun business in terms of its public appeal. I think when we launched or unveiled it in late 2018, we got a tremendous amount of press. I think there's a lot of people that love drones and flying drones just because of the perspective it gives you on your little phone screen display, gives you the sensation of flying. And I think people want to fly in a drone. We just have, it's really, I think, touched on the imagination of a lot of folks, including Jeff Bezos, who invited us to his pretty exclusive Mars conference in 2019. We were fortunate to be contacted by the Today Show and were profiled on a Today Show segment back in 2019. We were invited out to Dubai and presented the aircraft to the Crown Prince of Dubai. We got a lot of attention in the Middle East, as some of you may know, both between Saudi Arabia and Dubai and others. There's a lot of eVTOL interest, as well as actually in Korea. We were invited to a UAM exhibition along with EHang in 2020. And I'm sure many of you know as well, the U.S. Air Force is heavily getting into the space, and we had a very great opportunity in late or mid 2021 to do a flight demo inside Texas football stadium, which is wonderful for me, being my alma mater. It was an amazing experience to fly for the vice chairman of the Joint Chiefs of Staff. What else? Oh yeah, so we have a whole thread of kind of U.S. Air Force and military development. We've had a number of SBIR awards. We have a cargo variation of the aircraft, which I'll show in a second. And we really benefited from a lot of the R&D funding that AFWERX and the U.S. Air Force, and in particular the Agility Prime program, has afforded us. They're just being wonderfully supportive. They basically said, hey, tell us what you're doing anyway. What's your flight test program? Let us fund that. And simultaneously, we'll be sort of evaluating these aircraft for military use. But it's been a great thing. It hasn't been. I thought it might be a distraction. It hasn't as yet been a distraction. They've been wonderful to work with. So kind of the way we're thinking about the market here is, we're starting Part 103. So there's a big market, we think, for just kind of entertainment and recreational use of eVTOL, as you all know. That's the topic of the working group, right? So, we're launching, I think we'll be the first in the world to launch this type of service. And we think it's going to be great. It's going to be profitable. We can charge more. People are okay with pretty short flights. From a liability and a safety standpoint, it's a much lower safety bar to pass. Again, we're not focused on safety. We're incredibly focused on safety, but it's not like certified. These aren't certified aircraft, and so you don't need to go through the full FAA certification process, which is going to take multiple many years for others. And so we saw it as a quick way to market. Our pilots are going to be educated about ultralights, understand the risks they're taking, and sign waivers, that sort of thing. And we hope, our goal is to make Hexa 10 times safer than general aviation, right? Which is sort of one fatal accident in 10 to the -6. One time to the -6. I think that's 100,000 hours of flight. So, in addition to entertainment and recreation, obviously we're already working with the U.S. Air Force on military applications. That's a huge market. There's, Johnny's, public services group, this emergency response and public use, an enormous market as well. And as I mentioned in the beginning, we think our single seat ultralight, while it may require certification to fly over congested areas and serve transportation use cases and missions for urban air mobility, that's an enormous market, and we're going to sort of leverage these early beachhead markets to pursue kind of a more traditional transportation use case in the future. Kind of double clicking on the public use, even though it's a single seat, there's a number of missions. Really, the wonderful thing about this aircraft is that anyone can be trained to fly it in less than an hour. And actually, we just proved this with a news personality, celebrity who recently flew Hexa, and will be airing on a major sort of news program relatively soon. It was our first non sort of employee test pilot trained pilot to fly Hexa, and it was about a 30-minute training process. So what's great about that, and under Part 103 rules, ultralights can be flown by anyone without pilot's licenses, right, including for public use. So any law enforcement officer could be a first responder in Hexa for search and rescue, Coast Guard purposes, obviously taking advantage of the amphibious nature of the vehicle. Firefighting is another great use case, as well as EMS, right, by air ambulance. We can get an EMT on scene, we think, up to 50% faster than by ground ambulance under certain circumstances. So this really is, I think, going to save a lot of lives. Real quick, this is maybe one of the first times I've shown the design for this, but Hexa is modular by definition. So this top rotor section can fly on its own. And we've designed basically a cargo leg attachment that allows you to basically fix a pallet in, and it can move up to 150 kilograms of payload, which is a wonderful thing. The Air Force sort of helped to sponsor some of the development of this, and we're flying a prototype of this already. I won't go into too much detail, except I already mentioned, one of the things I love about recreation is that this rental model is allowed under Part 103, and we think it's going to be wonderfully profitable, and it's going to allow us to develop our first vertiports in suitable areas to fly under Part 103. And we asked ourselves, of course, early on, does anybody actually want to fly these things? And so, being sort of a serial entrepreneur, I would love to get, market feedback. So we actually filmed a video of me flying this early on and says, hey, does anyone want to fly this? We did some Facebook and Instagram ads, and we got just a wonderful response, including over 15,000 people on wait lists to fly, with almost 5,000 kind of prepaid flight reservations. We have wonderfully patient people kind of waiting for us to launch, that remain very excited, even a couple of years down the road, to be one of the first to fly. So real quickly, we'll go through kind of our evolution of the business that we see. First few years, we're going to go market to market, city to city, and open our first vertiports, right? And so you don't need a network of vertiports to start, because for entertainment, you can just take off from a pier on the San Francisco waterfront, go tool around Alcatraz and Treasure Island, and come back and land. You don't need a network to start. So it's a wonderful way to start building out vertiport infrastructure, we think. As well, you can actually build multiple vertiports outside of controlled airspace, and over uncongested areas that people can use to fly around in scenic areas, still under Part 103. In longer term, we do see, opening vertiports that have routes over congested areas, which then requires, a certified aircraft. And that will require then some sort of pilot's license that, they're being developed actually now. So as I said, we have this tour we're planning, 25 cities. We're going to bring this wonderful tour trailer around, let folks fly, get familiar with the experience of eVTOL flight. And we are also working on our first permanent vertiport, which is going to be just outside of Central Austin on a cliff overlooking beautiful Lake Travis, which is going to be a wonderful place to fly Hexa for training. So kind of in summary, we're in production of one of the first eVTOL aircraft focused on this short range single occupant mission. No FAA certifications required or pilot's license required under Part 103. Focused on building vertiports, with the first one should open by the end of this year. We have a plan to have 28 by the end of 2025. We'll also be serving over 15,000 people on a wait list for our tour. Again, already in production. And we actually already have received a military flight release, initial airworthiness for DoD flights, and then I mentioned have a whole bunch of R&D funding from the Air Force. So that is all of the regularly scheduled program I have for you all. So I'm happy to take questions.
That is absolutely fantastic, Matt. And I mean, in 5 years, I'm sure they seem long to you, but what a lot you and your team have accomplished in a relatively short amount of time.
That's it. It always seems like you're moving slow on a day-to-day basis. It's at least not as fast as you'd like. But then you're right. When you look back over the course of just a couple of years, it's been we've managed to accomplish a lot. So
yeah, I mean,
really
look at everything on the page here. That's just amazing and thrilling for you're sort of at the tip of the spear of really cool things to come, and you guys are making it happen. So that's just really exciting. I did have a question. You had mentioned that you did a demonstration in Korea with EHang, which is another sort of similar aircraft in that it's a single pilot, operation, but there's a lot of differences in terms of how it operates, and I think maybe even in safety too. What would you say about comparing and contrasting Hexa with EHang's aircraft?
Yeah, that's a great question. They are one of our closest competitors, and I think they're onto a very similar mission set, right? They're focused on the sort of short range intra-urban flights, which I think is where the biggest need is. They're pretty far ahead of the game in terms of the number of aircraft and test flights they've done. They've flown many flights actually with passengers. Now, one of the things I'm a bit skeptical about, so their aircraft they're pursuing is actually 2-seat. There is no Part 103 in China, and their aircraft doesn't conform to the weight requirements of Part 103 per FAA. So it will need to be certified. And what I think is a little bit of an Achilles heel in their strategy is that they are going for a fully autonomous aircraft. There's no joystick, there's no flight control mechanism on board the aircraft, which is going to be really, really challenging to certify. And I think it's being fully autonomous is very different than just using automated flight controls to fly like waypoint missions. There's a lot more that goes into that. I think it's going to take them. I mean, there's no basis for flying fully autonomous aircraft today, and so I think it's going to be very hard to certify. I don't think it will be certified certainly by the FAA or EASA for a very, very long time, if ever. Who knows what China's the CAA is going to do in terms of certification, but we'll see. I think they're onto the right kind of short range mission segment, and it is a simple aircraft. I've seen it fly. It's really, really well tuned, stable, safe looking flight. But without a pilot on board to help contribute to the kind of decision-making processes, I'm a little skeptical that it gets approved.
Yeah, that's interesting. I get a little nervous about low rotors because we're talking about taking these aircraft out of the safe confined space of controlled airfields and potentially operating them, almost in general public. And we're going to everyone, I'll tell you, next month, we've got our guest speaker will be Peter Turnstrom from Stockholm, Sweden, who's the co-founder and president of Jetson. And they have an open rotor aircraft with low rotors and so that'll give us an opportunity to ask questions about mitigating safety and things like that along those lines, which is important. But, Matt, one of the things that strikes me about Hexa is you've got these high rotors that are sort of 8 or 10 feet off the ground, out of harm's way, plus floats, plus a ballistic parachute, plus I think you mentioned you got a couple redundant computer systems here. So you really focused on creating a bubble of safety around the occupant and aircraft.
Yeah, there will be mishaps with open rotor designs, right? We actually designed the height of Hexa to be out of reach for 98% of adults, right? So if you're super tall, you might be able to reach up and get your fingers in the rotor plane, but the vast majority of people, can't, won't, unless they're on a ladder and there's a mishap. There are open, but they're up and out of the way. I share your concern for, open rotors down low. The other challenge with open rotors down low, and in particular EHang's design, is in high winds, even moderate winds, these aircraft have to land with a pretty significant degree of bank, and so. I haven't looked at EHang's sort of the exact bank angle that would cause a collision, with the ground as you're landing, but they're pretty close to the ground. We've landed at, you can land at 20, 25 degree bank angles in these aircraft in high winds. And so you don't want your rotors to collide with the ground while spinning, of course.
That would be catastrophic, and I'd never thought about that. And of course, that makes sense. Like that, there's going to be situations where winds start gusting after the aircraft's already aloft, and then what do you do?
Yep.
Yeah, please go ahead. I wanted to open up to other people other than me to ask questions.
So it looks like we have a question from Saren, and then we also have some raised hands as well. Saren, I don't know if you want to speak or if you want me to read your question. Bye.
Hi, yeah, no, I can knock. Excuse me. Yeah, so I just had a couple of questions. Do you see contracts for your rental platform with public services, tourism, short-range commuter transit, or is the potential to just sell to these types of users? And then also, how do you see the public acceptance with multiple vertiports and short ranges?
Yes, yeah, great questions. Great questions. Yeah, the rental model, you know, is explicit in Part 103, and it is, you know, all of Part 103 is really for recreation and sport use, which is not very well defined actually, except that, you know, there's a fairly lengthy advisory circular 103-7 that says, hey, clearly these things are not recreation and sport, and it basically talks about, you know, flying for hire, right? Getting paid to do things with the aircraft. So that's more commercial use. So, you know, we kind of interpret recreation and sport to also kind of include, you know, almost by definition, kind of personal use. I'd love to hear what you all think is, you know, like, is, you know, people today clearly fly themselves around in ultralights and light sport aircraft, and they sort of go from point A to point B and maybe back from point B to point A. People fly, they do cross countries to go to Oshkosh in light sport and ultralights. So the rental model, we're going to start this kind of as a kind of beginner training model for consumer use under sort of the umbrella of recreation. Now, for personal use, so going from kind of point A to point B, with, you know, for personal use, I think it'll be, you know, we're trying to get more clarification. You asked about also public acceptance. That we're super excited about. We think the best way to go get public acceptance for eVTOL is to let people start flying, right? And flying outside of congested areas first makes a lot of sense. And so that's what we're doing. So, you know, we're going to build lots of data on safety and noise and other things that, you know, are important to the public. And we're going to do it in a safe manner, and only then sort of look to, you know, once obviously get closer to urban areas, and especially flying over urban areas, that's going to be a whole lot different than sort of what we're doing in the first few years. So, you know, we also, what we love about this ultralight concept to start and our pure hover design, and not only pure hover, but not using coaxial rotors, is that it has about the lowest disk loading you can imagine for an aircraft to lift a person. That's basically all it's lifting, and it's just purely designed for that. And so it's much quieter than lots of other eVTOL aircraft that have coaxial rotors. You lose, you know, 15-20% efficiency typically, which you got to make up with higher RPM. And so we think it's maybe the friendliest aircraft to like get the public exposed to flying. And believe me, I'm envisioning, once we get people flying these in mass for these sort of beginner flights and just giving people a taste of what eVTOL can do, everyone's going to be begging to fly these everywhere, right? And for all sorts of missions, public use missions. Already we have interest from, you know, the police sector, military sector, EMS. But once people realize that, you know, these aircraft can get, you know, a single person with almost no training, and a decent range. It's I think there's going to be a groundswell of interest and need to put these for other uses. So I think I answered your question.
That's
definitely.
great.
It makes me think of like resort rental tours and things like that.
Yes, yeah. I mean, when people are flying around from a resort or from one of our vertiports, and like, why can't I land this at the airport with a bag and catch a flight? I think people are just gonna start to demand expanded use for this.
Saren, do you think this would be popular in Hawaii?
Oh, definitely. Yeah, for sure.
Hey,
yeah.
Don, I noticed your hand up first, and then Steve. Maybe you could do your question after Don.
Yeah, hi, I'm Don Birchoff, True Weather Solutions. Nice to meet you. I think, this is amazing technology. As a Air Force retired guy myself and been in the weather business for 40 years, I'm always looking at, okay, so, micro weather, right? And how micro weather can surprise and thinking about who might fly this and how well trained they'll be on using the right weather sources and products, which aren't good enough today really for micro weather. Have you considered that? And the other thing I want to ask is, when you said it could take high winds, what's your definition of high winds? Yeah.
Yeah, great question. One of the things when we say anyone can fly this, and there's others in developing eVTOL aircraft that are in Part 103. We're not alone here. What I think differentiates us somewhat is this controlled flying experience model. Like to be honest, I think selling these to people to fly around their own property or fly themselves in uncongested areas is not as safe as I think it should be. It leaves the weather question up to them, which I think is bad.
Yeah.
So
I'm going to tell you just what I'm seeing with drone pilots that don't have aviation experience. It's people think what they get on TV is good enough, and they don't really understand, how things change. And just looking at that route you have going across the bay there, I mean, I know the weather could change on one side of the bay to the other, So I'm just wondering, because I mean, we're having enough trouble today with that. And fortunately, we haven't done BV loss yet, so that's going to be even a bigger factor, right? But anyway, I'm sorry, I just
no. So, as it relates to micro weather, this is a micro flying experience, right? Especially when we're flying point A to A, right? We will do our best to, and we will have a fly, no fly rule, right? And that will likely also have different tiers for different levels of experience of pilot. If it's your first beginner flight, you're not going to want to take off in a 25 knot, wind with 30 knot gusts, right? You're not going to have fun. You know how these drones fly in gusts. They're pretty jerky. They're stable. And like I said before, landing at a big bank angle is a little unsettling. So beginner flights, we think, will keep really below 20 knots in terms of consistent winds, maybe even 15 to 20 knots with gusts maybe up to 20. Beyond that is going to be more advanced. You can fly, we've flown, I think, in up to 30 knot winds. We're slowly expanding our flight test envelope, I should say, our whole flight test approach. And this is actually a wonderful benefit too of controlling when and how people fly is, we can actually launch before we have fully tested the aircraft out to the very edges of its envelope, because we can limit that envelope entirely to a beginner envelope. So this first envelope is 50 feet or less, like below our parachute altitude, and with like I said, winds of like less than 20 knots. So yeah, and then our approach is to have our own sort of weather stations at our own vertiports for and to really become experts in the micro weather climate in these kind of small areas that we're going to fly.
Yeah, so I'll just say we'd love to help you become an expert in this because microclimate isn't, it's an atmospheric science and it's a scientist thing, right? So we'd love to help you with some of this because it's very interesting to me. And I could see all the challenges, but they're all mitigations, right? So the key is knowing what, knowing how to build a system around this that will be safe and be, really relevant to it. So, but thanks.
Okay, Chuck wants to jump in here. I wanted to back up what Don was saying about the micro weather and particularly about drone pilots not understanding the weather, or in fact, in many cases, much else about aviation at all. In my role as a range safety officer, I learned that pretty early on, and it was pretty daunting. So I can back that up, and Don, if you want any help from a pilot, I'd be happy to jump in. But Matt, I had a question for you regards to weather, and Don kind of touched on it. Are you planning to gather real-time information from the aircraft on flight dynamics? In other words, in many drone operations, of course, you can actually tell what the wind is based on GPS and all that sort of thing. It would be probably useful if you could pick this information up real time in order to control dispatch and improve safety.
Yes, yeah. In fact, we're working on that problem right now. Not less for kind of mapping real-time weather in our flight area, but which I think we will do. But we also want to have a real-time range indication for the pilot, which incorporates the weather, the sort of instantaneous present weather that the aircraft is in. For example, the range you can go is not just a circle, right? As soon as you introduce winds, it's more of an ellipse, right? So we're in the process of gathering exactly that. It's pretty easy to deduce like what the winds are, using obviously the IMUs and the autopilot information, and we think that can be pretty accurate. And then from there, we're going to base sort of the range, and communicate to the pilot, the effective range, including the winds. But yeah, that's a great idea to actually use that to map, real-time or near real-time micro weather information. Yeah, each aircraft will be a little weather station, really.
To back up what Don was saying too, back to the same issue, not to beat it to death, but of course, non-aviation types don't generally understand that the wind at the surface is not the wind 100 feet up. So at 30 feet, you make a measurement, and at 100 feet, it's going to, check me if I'm wrong, Don, it's going to veer and increase at least 10%, correct?
10% on a good day. Yes, it could be 50%.
Sure, absolutely. And that's why I think that being able to gather the wind information real time is really important in terms of the range of the aircraft, or the effective range of the aircraft.
That's a good point. Hey, everyone, we have about 10 minutes left, and I definitely wanted to get to Steve Tibbitt's question. And then after that, we'll maybe let Matt off the hook, do just a minute or two of shop talk about the paper, and then we'll be on our way in about 10 minutes. So Steve, take it away.
Hey, Matt, great job. We think a lot alike. I appreciate what you guys are doing. It's awesome.
Thanks.
My question is, your website says your vehicle sits at about 432 pounds. And I want to know what your secret sauce is in getting the 103.
Yeah, great question. So we use allowances that are provided for. If you just read Part 103, there's actually we don't conform. Yeah, Part 103 is like one page in the CFRs. It's shockingly little, but if you haven't read it, I invite you. Really, there's so much.
I've read it like 4 times trying to figure out how you did it, and the only thing I can figure out is maybe you're counting all 7 floats as individual 30-pound elements.
Yes. That's
that what you're
exactly
doing?
what we're doing.
Okay.
That's
awesome.
yes. Yeah, and that's allowed for in the regs. They multiple floats is, it's hard to have one float and not flip over. So multiple floats is fine. And we got we of course asked our local FAA FSDO prior to even designing the aircraft, kind of to confirm our interpretation of the float allowance. Now we do use more floats than a lot of other aircraft do, but that is that kind of goes with out of necessity by the way drones fly. You don't just land going forward as you do with fixed wing aircraft and things, right? You actually have to be able to land aimed into the wind in any configuration. So we needed a radial float pattern, and we needed to distribute a certain amount of buoyancy around a radial pattern, and so the kind of result is what we got. So yeah, we conform to that, including allowances, and there's an additional weight allowance for the ballistic parachute.
Right. Thanks. That clears it up. I want to circle back a little bit on the weather thing, but what I see, I do know that, for example, some of the commercial jets have some kind of Doppler radar for clear air turbulence and things like that. Wouldn't it be cool to develop a system like that was super lightweight? Because I mean, my experience as a pilot is the thing that really gets you or freaks you out is clear air turbulence, where there's no indication of this thing coming, and all of a sudden you're flying, knife edge down, wingtip down. So I think that's the most insidious thing that we have to face, really.
Yeah, that's a good point. One of the things that we're thinking about is, given the limits of Part 103 and the weight requirements, right? It's tough for us to pack a lot of, like, we're measuring in grams here. Like, we can't pack a lot of sensors on board. But because we're flying in these pretty limited controlled areas, we can use ground station equipment, and ground-based radar, other ground-based systems to do all sorts of other sensing, including, sense and avoid for airborne, other aircraft and even birds or small drones. And that sort of thing. And so it'd be interesting if I'd look into, I count that as kind of a micro weather system that we could look into what we could figure out using even ground station equipment.
Sure. Great idea. Thank you.
Outstanding. Matt, from all of us, thank you so much. This has been super cool to see, and it's going to be even cooler to see the progress that you make from here, because you guys obviously have a lot of momentum.
Yeah, we'll be flying soon. I hope you all sign.
That's awesome. Yeah. I know everybody's looking forward to jumping on board. This is super cool. So thank you very much for doing this today. We appreciate it, because we see how busy you are. Okay. Yep.
Pleasure.
So we have about 5 minutes left, and I just wanted to bring up that Carter and I had a good chat lately, just about, because he's working on some technical stuff with regard to airspace issues. And that's one of those things, especially anything technical, once you get into the weeds a little bit, there's really no limit to how deep you can go and how broad you can go. So I was going to ask Johnny, if you're still on, Johnny, what would be your advice for us in terms of how we kind of keep an eye on our breadth and depth when we get into technical issues? Because I know it's something you tackled in your public safety paper. You did get into some tech stuff, not too deep, and it just seemed like it was a good overview. You didn't make a lot of recommendations. You just said, look, this is the state of what's going on, and how, where do we draw the line, Johnny?
Well, first recommendation is don't even touch it. No, just kidding. Actually, I kind of played it by a little, we started drafting, obviously, with multiple authors. Some area we got a little deeper, some sections we got real deep. So I start to grab a few volunteers from moderate technical level some in the industry, a couple in the not in the industry. I just asked them to not the whole report, because sometimes that gets too much for the volunteers. I said, well, those are the few areas that we try to balance out. How about if you, from non-author perspective, become an audience perspective? I say, how about if you just quickly glance through it, give me a few thoughts about where you think is too much and where we should cut it off, and we basically work it back and say, okay, let's balance out in this what I call the generally readable. We try to stay away from the PhD thesis level, which will be nice. I mean, many of us are technical backgrounds, so unfortunately we have the tendency of enjoying that stuff. But from the readership perspective, we try to define who is our reader. It's not the super deep technical folks, but the industry leaders, the potential government leaders in different departments and so on, and the public service operations, either the firefighters or the fire chief or the other potential user. So we try to put ourselves in that mindset and say, okay, where do we try to balance out? Yeah. I don't think there's a perfect answer, but try to envision your main target audience and what they would be comfortable with.
That makes perfect sense, because that's exactly right. Safety is important. We want, it to be, end users who aren't necessarily pilots or technical, but that are considering, how this will work and how to operate safely, and what the structure would be. So you did a good job of balancing sort of like giving an overview versus giving a lot of recommendations. It seemed like you just, especially on the tech part, you just kind of said, look, this is the state of what's out there. How should we be making recommendations, or should we be focusing mostly on just reporting what the state of the situation is?
Well, my personal view is that, we're envisioned to be in a NASA paper. So some forward-looking should be good, actually, to some degree. So what we're trying to do, in line with our roadmap mission and obligation, to say, okay, here's some of the area that has been addressed to some degree, envisioned to be production ready or industrial ready. Here's a few areas that's still unsettled and still challenging. The current industry status may need some more innovative solutions. I don't think it's anything wrong that we put out a few possible directions. We don't necessarily provide specific one solution, because if we only provide one solution, I think that may be viewed as a little biased.
Yeah, that's not our place.
From a white paper perspective, if we were to provide potential outlook and possible alternate options, it would be nice to have a 2-3 as example. I would use the word as example. Those may be the plus other that we haven't confused. Yeah, that would be my thoughts. Yeah.
That's Johnny. That's great. And that brings us up to time. I've got about 3 o'clock Eastern time and noon Pacific. Great meeting today. We're so lucky to have Matt Chasen as a member, and I thought that was a fascinating talk. Next month we'll have, as I mentioned, Peter Turnstrom with Jetson from talking to us from Sweden about their progress and their aircraft, also Part 103 compliant ultralight vehicle. So and there's some pretty cool videos of Jetson flying around. If you haven't seen those, check them out. I'm going to let everybody go. It's 3 o'clock. Thank you very much for jumping in today and being a part of this. We really appreciate it. And we'll see you at subgroup meetings, hopefully. Get in touch with your writing partners for your individual sections. Set up your subgroup meetings between now and then. I'm happy to join in. I like doing so. And we'll keep trying to build our forward momentum with the white paper. So thanks for all that you're doing. Check out the in the meeting notes. I've got the links to the where the drafts are. Check out what everybody's doing. We've got, there's like 4 draft papers in there, including the one that Chuck and I are working on. I know there's some great work by Dr. Pavel is in there. It's worth a read, and it'll start to coalesce when you're seeing what everybody else is doing, and then we're gonna start to glue it all together. So we're getting there, and we're gonna keep our forward progress. Thanks, everyone.
Thanks.
Thank you. Hey, great meeting.